Welcome to Automated Visual Software Analytics. This part is about code duplicates. We will have a look on code duplication in general, on code similarity, and we will discuss consequences of code clones. Code duplicates in general denote repeated code sequences. They can result, for example, from copying and pasting code segments in a given software project. They are called code clones. They can also result from independent development activities leading to code that shows similar behavior. In general, they tend to evolve independently and in all long-term and large software development projects. Interestingly, code duplicates are never explicitly visible or recorded in a list, so we have to identify them in an independent stage during a static source code analysis, for example. Repeated code sequences tend to violate also the principle "don't repeat yourself." There are many reasons for code duplicates. Some reasons are listed here. One of the major reasons is copy and paste. Developers like to reuse existing solutions and to adapt these solutions later on. However, as a consequence, they introduce a code segment that has a significant similarity to an existing part of the software system. Also, forking, templating, customization of codes lead to code duplicates. There are some more reasons that are related to the general organization or the principles applied during software development. For example, in general, many developers do not have sufficient information on a global project scale. Maybe the reuse process is badly organized. There's also a more intrinsic and subtle phenomenon. If, for example, the productivity of a developer is measured by lines of code per day, there's a certain tendency to copy and paste code segments because this leads to a high number of lines of code per day. Time pressure may be also a big issue if a solution has to be found instantaneously. Educational deficiencies, intellectual challenges, for example, if generic programming is used, professionalism, end-user programming sometimes shows a high degree of source code duplicates. Maybe during the development process there are some reasons that lead to code duplication and, of course, organizational issues such as distributed development organizations and development activities. So you see, there are not only technical reasons for code duplicates, there are many reasons in the software development process as well. So code similarity is the underlying concept used to detect code duplicates. Code similarity is a broad term, and one way to define code similarity is a program representation-based similarity. This is about text-based clone search, so it's a syntactic match that is performed on all parts of a software system to find out whether a written part of an implementation looks like another part. So the syntactic similarity is used as a key principle. Token-based clone search can be applied as well. It's especially robust against reformatting, documentation changes, or renaming of variables, functions, classes, or methods. There's also one approach called abstract syntax tree-based code similarity that is especially robust against differences in keywords or parentheses. In general, if we want to identify similar code, we have to apply normalization on the implementation, at least during analysis, to further detect equivalent code segments that are considered to be the same, at least to have a significant degree of similarity. Yeah, for that, for example, many tools form so-called characteristic vectors that are high-dimensional, that contain the number of variables used, the number of keywords that are used during an implementation, and they want to find out how similar are these high-dimensional vectors in order to detect similar code. There's also another approach to detect code duplicates. It's called behavioral similarity. For a code sequence, all variables that read are denoted as input variables, and all variables that are written are denoted by output variables. Based off both groups, input variables and output variables, we can interpret a code segment as a function from valuations to the group of output variables based on the group of input variables. And two code segments are called behaviorally equal if and only if they have the same set of input and output variables. Of course, renaming issues are considered as well, so modulo renaming. And they are equal with respect to their function interpretation. This approach offers more degrees of freedom and can detect code duplicates that are more subtle in the sense of that they vary regarding their syntax, but they are similar regarding their functional behavior. In the fields of code similarity, we can differentiate between different clone types. These clone types are categorized according to their textual and semantic similarities. Basically, we distinguish between four types. The first type is simple. It's an identical code fragment. Identical means literally the same written implementation except whitespace, layout, or comments. Whitespace, layout, and comments can be easily normalized and this way can be ignored. Type 2 refers to syntactically identical fragments except for variations in identifiers, literals, types, whitespace, layout, and comments. So we have fragments that are at the first glance different, but if we remove variations in identifiers, then we come up with the same implementation. We can see that it's the same implementation. So this is type 2. Type 3 refers to copied fragments with further modifications. Further modifications means, for example, changed, added, or removed statements in addition to variations in identifiers, literals, types, whitespace, layout, and comments. So you see that these types more and more open the range of similarity. And finally, type 4 means two or more code fragments that perform the same computation but are implemented by different syntactic variants. This is the most difficult form of code clone that can be detected. Type 3, further modifications. This is the key part here. All these types are relevant to software analytics. Of course, we would like to identify these different types, especially type 3 and type 4. Give you some examples. Type 1, this is just an excerpt of an existing implementation, and what you can see is that both parts of the software represent exactly the same implementation, so it's a type 1 example of a code clone. That is easy to detect, of course. maybe even due to or based on just looking at the source code, but we need, of course, more systematic ways to detect code clones. Another example, type 2. Here we have some variations in identifiers and parameters. For example, there's a different file name given, and some parameters, here's the image sizes, it refers to some graphics programming stuff, are different, but the rest appears to be similar. So both code fragments are considered to be clones, although there are some variations in identifiers and parameters. Finally, give you one example about a type 4 code clone. This is, of course, extremely difficult to detect and even to comprehend. For example, we have here a part of a source code that draws some graphics, actually a cube. And this can be formulated, coded functionally in an equivalent way by these statements below. But of course, it's difficult for tools to detect this kind of code cloning. This is maybe up to experts to detect this difficult way of writing the same code twice. Yeah, this illustrates how code clones work. There are, of course, different methods apart from the syntactic comparison. For example, one recently developed method is called count matrix clone detection. It is based also on providing and setting up vectors that denote similarity, that capture the usage of variables, and based on these vectors, here's the intuition, is that if two code fragments are indeed clones, then a variable in one fragment will have a counterpart in the other fragment that is used in very similar ways. And this means that the count vectors will be similar. Because this is the key idea how to tackle the difficult problem of finding code clones apart from syntactically equivalent implementations. This is easy, so type 1 is easy, but type 2 starts to be more difficult, and type 3 and type 4 are extremely difficult today for tools we have to be detected in large software projects. Yeah, there are some tools, as I already said. It's a growing market of tools that aim at providing services that allow you to detect source code that is duplicated. For example, Duplo, Simian, Clone, Doctor, Conquet, Atomic are examples of such tools. You may have a look whether these tools fulfill the needs in your project. Sometimes clone detection is highly dependent on the programming language. So there's no general purpose clone detection tool that could be applied to all kinds of programming languages. It's always, to a certain degree, specific to a programming language. Yeah, what are the consequences of code clones? Why would we like to detect duplicated code? Basically, for a number of reasons, and the most important one is if errors are fixed or functional changes are made, all instances of duplicated code have to be identified and modified. And if they are not identified, you change and you fix an error for one instance, but it's not fixed for the other instances. So if code is improved, you have to be aware of where are the duplicates, such that you can apply your bug fix to all instances of the implementation. If you don't know about duplicates, of course, you fix it in one place, but you forget to fix a bug in other places. So this represents a long-term negative consequence of having code duplicates in a software system. Repetitions also indicate generally failure to use appropriate abstraction mechanisms, for example, to factor out same functionality by subroutines, functions, methods, subclasses, or templates. As you can see, these are already the ways you can solve code duplication, basically by using abstraction mechanisms that are part of today's programming languages, for example, subclassing in object-oriented languages or templates, kind of generic programming in C++. Another consequence is if code is heavily duplicated, of course, the size of the system grows. Another general defect is that you get an inconsistent change which leads automatically to a growing number of faults in the system. Yeah, redundant code also hinders software maintenance and, of course, increases the costs for software maintenance. Code duplicates are both a threat to software quality, which is obvious, but also an opportunity for improvement, for improving the software quality, for improving the system structure, for improving the software implementation. Let's summarize this part. Code clones occur in nearly all long-term projects. There are different causes for code cloning, like copy and paste, incidentally cloning, restructuring artifacts, etc. Code clones impact, of course, software quality in a negative way. Software maintenance is hindered and respective costs grow. Error handling becomes extremely difficult if there's a large number of code duplicates in your software implementation. Specialized tools for code clone detections allow you to systematically identify code clone suspect parts, and you can then react by restructuring, refactoring, or abstracting these parts to reduce the amount of duplicated or similar code. In software analytics, we use code clone detection information as a base information used to report on the as-is status of a software system and as a key input for prediction analysis. Because if we know that's a code clone, we can predict, together with some other metrics, that this part most likely will become a dangerous part or an error-prone part in the future. So code clone detection forms a kind of base information that is essential for software analytics. This finalizes this part about code duplication, and let's come to some terminology issues, especially code clone. A code clone is a segment of code that is identical or similar according to some definition of similarity. Syntactic similarity, semantic similarity, behavior similarity. The notion of similarity can be based on text, lexical, or syntactic structure or semantics. As further reading, I can recommend the survey of research on software clones from Rainer Koschke. And finally, let me give some remark here. Cloning can be a good strategy if you have the right tools in place. Let programmers copy and adjust, and then let tools factor out the differences with appropriate mechanisms. This is a very pragmatic view on dealing with software cloning, because it basically tells that software duplication, software code cloning can also be a chance, especially if you're under time pressure. You can write faster an implementation, but you should be aware that at the end you have to find out code duplicates but there are some tools that help you, that assist you in identifying those parts that are considered to be similar. And this will then improve, of course, software quality at a later stage.